Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Rizca Wulandari and I'm a student of Industrial Engineering in Basmati University. I'm going to talk about my research with Professor Joko Triyono and Mr. Eko Pujianto. The title of my research is Multirespond Optimization in Injection Molding Process of PLA bond screw using Taguchi method and response surface methodology. And this is the outline of my presentation. The first is introduction, and then experimental design, Taguchi methods, response surface methodology, experiment confirmation, and the last is conclusion. Some of the reasons behind this research are fracture case every year is increased. In 2018, the prevalence was 5.5%. Bone grafting with metal material also has several side effects, namely hypersensitivity to cold, decreased bone density which has the potential to result in bone atrophy. Metal can also corrosion problems, so the use of X-ray, CT and MRI may be a risk in radiotherapy patients. In open reduction internal fixation or ORIF, the patient has to undergo two operations for bone grafting, namely the installation and removal surgical screw, so it causes more. From the previous research on a bone screw injection molding carried out just by simulation. And this is the design of bone screw. This design from previous research. The type of the screw is cannulated screw with the length 24 mm and the diameter is 9 mm. Material that used is polylactic acid or PLA. To reduce the operation and some of risk posed by metal screw made from biodegradable material can be a solution. Biodegradable material are self-biodegradable in the body, so that no surgical removal of bone screw is required. Polylactic acid is a polymer that has high tensile strength, modulus, good biocompatibility, which make it more suitable for load-bearing applications such as sutures, tissue culture, blood closure, and orthopedic fixation. This is the table of setting level and experimental factor for PLA material. There are 4 factors with 3 different levels: shoot size, melt temperature, injection time, and the last is cooling time. And for the response are shrinkage and density. After that, next topic is Taguchi method. This is the table of L9 orthogonal array that used in this research and the result from the experiment. After getting the results, then calculate the SNR point. And then after getting the SNR point, calculate the wake point and get the result as in table. Optimal level setting with Taguchi methods are 7 mm at shoot size, melting temperature at 110 degrees Celsius, injection time is 2.5 seconds, and the cooling time is 10 seconds. And the next topic is response surface methodology. This is the result of ANOVA for response density using software design expert. And this is the equation model for each response in determining the optimal setting in this study or regression model using design expert software. And this is the table of the result of ANOVA for response shrinkage. And then this is the equation model for density and screen peak by using software design expert. And table above is the table of the result of desirability, and the optimal desirability value at the shoot size factor at 7 mm, melting temperature of 105 degrees Celsius, injection time for 3.5 seconds, and the cooling time for 10 seconds. And this is the response surface plot for density and shrinkage response. Okay, the next topic is experiment confirmation. Based on the result of the tests that have been carried out for confirmation experiment that shown in the table above, with the average shrinkage yield obtained in 0.445%, it can be concluded that it is optimal because in the shrinkage value range for PLA is 0.2 until 0.5%. The result of the average density obtained is 1.229 gram per centimeter cubic. It can be concluded that it is not optimal because it does not match for the PLA density value, namely is 1.25 gram per centimeter cubic. And the last is conclusion. There are 4 conclusions. The first is the optimal level setting value with Taguchi method is in the shoot size condition of 7 mm. The melting temperature is at 110 degrees Celsius. The injection time is 2.5 seconds and the cooling time is 10 seconds. Where in the response surface methodology method, the optimal level setting in the shoot size is 7 mm. The melting temperature is 105 degrees Celsius. The injection time is 3.5 seconds and the cooling time is 10 seconds. Factors that influence the shrinkage response are all factors, namely is shoot size, melting temperature, injection time, and cooling time. Meanwhile, for density response, only 2 influence factors were melting temperature and cooling time. Okay, this is the end of my presentation, and thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.